So, hello everyone. This is May from Let's Learn. Today we are going to Q&A sessions with Rakshit. So, are you ready, Rakshit?
Yes, I am ready.
Okay. Whenever you speak, keep your mic here so it will audible. It may audible.
Okay, no
Okay.
problem.
So, first of all, what are the four strokes? What are the parts of four-stroke marine diesel engine?
Okay, the parts of four-stroke marine engine mainly involves first of all the cylinder head, then we have the head gasket, then the cylinder block, we have piston ring, connecting rod, gudgeon pin on the smaller side, crank pin on the bigger side, we have crankshaft, we have flywheel, we have timing chain or timing gear, we have camshaft, we have cam follower, we have push rod, we have rocker arm, we have wall springs, we have inlet and exhaust valves, we have fuel injector.
Very good. And how piston and connecting rod is connected?
Piston and connecting rod is connected by a piston pin or a gudgeon pin.
Good. What are the function of rocker arm?
So the rocker arm function is basically to open the inlet and exhaust valve with proper timing. This proper timing is given to the rocker arm by the help of camshaft, which has a profile which is made so that proper timing is given to the inlet and exhaust valves.
How camshaft and crankshaft connected?
Camshaft and crankshaft can be connected depending on the distance, either using a timing chain or a timing gear.
Very good. And explain three-phase induction motor.
Okay, the three-phase induction motor is a device which we use to convert electrical energy into mechanical energy. The main construction involves a stator and a rotor. The stator is the stationary part, the rotor is the rotating part. In stator, we have three windings at 120 degrees to each other. We supply three-phase AC current to it. Now, this three-phase AC current that is applied to the stator will produce a rotating magnetic field. Now, since this rotating magnetic field is there, it will cut the rotor, which will produce a EMF magnet due to electromagnetic uh, Faraday's law of induction, which states that whenever there is a relative motion between a closed circuit and a magnetic field, EMF is induced. So, like that, EMF is induced in the rotor. Now, this EMF that is induced in the rotor will produce its own magnetic field. Now, since there is a repelling magnetic field between stator and the rotor, a torque is produced in the rotor, hence it will start spinning on its own. So, hence we successfully have converted electrical energy into mechanical energy.
Good. What are the classification of pump?
Okay, the main classification of pump is as follows. First, we have rotordynamic pump and positive displacement pump. In rotordynamic pump, we have centrifugal type, we have axial type. In positive displacement pump, we have reciprocating type, then we have rotary type. In reciprocating, we have diaphragm or piston. In piston, we have single acting or double acting. Now, in rotary type, we have gear pump, vane pump, screw pump.
Okay. What are the some NDT methods?
Okay, the NDT methods that I know about is first of all manual inspection, in which we use our eyesight and feel of touch to know any imperfections in the specimen. Then we use magnetic particle testing, dye penetrant testing. Then we use ultrasonic testing and radiography testing.
Okay. What are the tools that we use on board ships?
Okay, the major workshop tools that we use in ship, first of all, we use holding tools such as hand vise or bench vise. Then we have marking tools such as scribbler, dot punch, or center punch. Then we have screwdrivers, which is flathead, Phillips, or even hex type. Then we have measurement tools like steel ruler, which is our usual ruler. Then we have vernier caliper, vernier height gauge, micrometer, bevel protector. Then for basically cutting process, we have hacksaws or files. In files, we have round type, triangular type, square type, half round type. And in power tools, we have grinding machine, we have drilling machine, we have lathe, we have powered hacksaws also. Then we have pliers, we have tap and die. So all of this are used in ships.
Okay, Rashid. If you need any help, you can use your textbook or your notes. Okay, in between your
Okay.
video. So, What are the use of piston rings?
So the piston ring, basically we have two of them. First is the compression ring, then is the oil ring. So the function are as follows. First of all is to maintain a seal between the combustion area and the crankcase side. So none of the combustion gas or the combustion pressure does not leak into the crankcase section. Second is heat conduction. The heat from the piston goes into the piston ring and further to the piston jacket, which will be efficiently cooled. And the third is to maintain a thin uniform layer so that metal to metal contact is reduced, also corrosion is reduced.
What is saturation temperature?
Okay, saturation temperature is the temperature above which vapor cannot be liquefied, or basically it's the boiling point.
What is sealing box? Why it is important in centrifugal pump?
Okay, sealing box is important in a centrifugal pump because, as we know, the casing is a stationary part and the shaft is a rotating part. So some tolerance have to be given. But since we have given some tolerance, there is a chance that air might come inside the pump or water might leak outside also. So we have given a sealing box so as to avoid this leakage of water and prevent the air from coming from outside to inside.
What is flywheel?
Flywheel is a mechanical component that we use in engine, which is a heavy mass object that we put at the end of the crankshaft. So the main use case of it is to absorb the mechanical energy from the crankshaft and supply it evenly across all the other non-power stroke, basically the intake, compression, and the exhaust. It also helps in reduction of noise, vibration, and also resolves any unbalanced force that is there.
And what is governor?
Okay, governor is a device that we use so as to maintain a constant speed across varying loads. So there are many types of governors. First of all, what we have learned in our labs is centrifugal type of governor. There is electronic governor also. In centrifugal, we have Potter or Hartnell. Hartnell uses spring. Potter does not use a spring. It is the lift is lifting against gravity. So the main principle behind governor is that this governor will be connected to the crankshaft through a bevel gear. It will start spinning. There is actually two fly balls which is connected to the spindle with the help of arms. Now this fly balls is also connected to the sleeves. So if the speed is exceeding a predetermined value, the sleeve will go up. Now this sleeve is further connected through a linkage to a fuel valve. If the speed is too much, this fuel valve, with the help of mechanical linkage, will restrict the flow of oil, hence reducing the speed. Now, if the speed is very low, that means the sleeve will start coming down. Hence, this linkage will make sure that the fuel valve is opened a bit more so that more amount of oil can go. So it helps in maintaining a constant speed. But that is mechanical governor. But right now we are using electronic governor. Basically, we are by using sensors, we are knowing the crankshaft rotation and its speed. And with the help of ECU, we can actuate the fuel valve for the amount of oil that is passing through it.
Can you tell the vehicle's name that we use currently, the governor, right now,
Uh,
currently?
governor, electronic governors is used in my scooty and car. Both uses electronic governors.
And what about school buses?
School buses use a different type of governors called as speed limiting governors, which does not allow it to pass beyond a certain limit.
Yes. What is camshaft?
Okay. Camshaft is a device again, which helps in opening the inlet and exhaust valves with proper timing, which gets its power from the crankshaft. Basically, the main ideology behind is that the piston is synchronized with the crankshaft, and the crankshaft is synchronized with the camshaft.
Your voice little bit. Yeah.
So basically, the principle is that the piston is synchronized with the crankshaft because they are linked with each other. Further, this crankshaft is also linked with the camshaft. So, with the help of camshaft and its cam low profile, we can maintain a proper timing of inlet and exhaust valve opening. So, that is the use case of camshaft.
Why we say the crankshaft ratio of crankshaft and camshaft is 2:1?
So basically, how much ever revolution of crankshaft there may be, the camshaft will only rotate one time. For how much ever revolution of crankshaft there may be. So the basic ideology is that this crankshaft revolution, it is rotating 2 times. It is because the entire cycle is completed in 2 revolutions. But for in case of opening of inlet and exhaust valve, this entire cycle has to be completed in 1 revolution of camshaft itself. That's why the camshaft only rotates 1 revolution.
What is Tappet clearance and why it is needed?
Okay, Tappet clearance is the clearance we give between the rocker arm and the valve stem when the engine is in compression, all the valves are closed, and then the engine is in cooled condition. It is given so as to because it is given so that we can account for the heat expansion that happens when the engine is in heated condition, so that proper timing can be even maintained when heat fluctuation happens.
What is turbocharger?
Okay, turbocharger is a device which we use in engines so as to increase the power and efficiency without increasing the size of the engine. So the main construction of turbocharger is like this. First of all, on one side we have a turbine, and another side we have a compressor with one shaft only. We are connecting both. So the first what happens is exhaust gas from the exhaust manifold with high kinetic energy will strike the blades of the turbocharger, because of which it will start spinning. Now, since this turbine is spinning, the compressor also will start spinning. Now, whatever air is there in the engine room, it will get sucked by this compressor and pressurized to slightly higher pressure. Because there is an increase in pressure, there will be increase in temperature also. We don't want this higher temperature air inside the engine because first of all, it has less density. Also, if we supply this high temperature air, there might be a chance of knocking also. So we are reducing the temperature either by air cooling or water cooling. This water cooling we can further incorporate into exhaust gas economizer also. So this high dense air and high pressure air is applied through the inlet port where it will provide sufficient scavenge pressure also, and because of density proper combustion also, hence increasing its power and efficiency.
And how we cool down the this air before sending into the engine?
I said no, air cooling or water cooling.
Yeah, air cooling. Okay. So I missed that point. Uh, what are boilers mounting?
Okay, the main types of boiler mounting involved, first of all, the is the feed check valve. Then there is pressure gauge. Then we have blowdown valve. We have scum valve. We have gauge glass. We have fusible plug. We have low water level indicator. We have air vent conch. We have steam stop valve.
What is the difference between fusible plug and bursting disc?
Basically, fusible plug is supplied so as to make sure that a certain predetermined temperature is not crossed. But in bursting disk, we are using it to make sure a certain predetermined temperature is not being crossed. So basically, a fusible plug is used to protect the system from excessive temperature. Bursting disk is used to save the system from excessive pressure. That is the difference between both.
Why AC in TR and freeze in liter?
Okay, there are many reasons for this. First of all, in AC, we do not have a predefined area. Basically, we can't generalize it because everybody's room will change, everybody's room liters will change, so we cannot generalize it basically. But for refrigerator, we are generalizing it because we are getting that same volume from the manufacturer itself. It cannot be changed. It is cooling that much amount only. The second reason is the conventional way of saying. It is very unconventional to say 0.45 tons of refrigeration for a refrigerator or 10,000 liters for an AC. So as to increase the convenience of saying, also we are doing like that. Third is for refrigerator, it is very important to know the capacity or the volume because we are actually storing vegetables or meat into it. So that also is one of the criteria. And another thing is that for AC, it has many variables to consider. People are coming in, people are coming out. There are some external elements also. So as to do calculation for all of this, it's much more complex than compared to a refrigeration system. So we are using in tons of refrigeration.
And what will happen if we keep the refrigerator door open?
Okay, what will happen if we keep the refrigerator door open? First of all, it will start trying to act as it will start trying to act as an AC, but it will be failing to do so because first of all, it is absorbing the heat from the air and rejecting it to the same environment itself. Also, because there is so much to cool, the compressor will start overloading, and that also will start emitting heat into the same environment. Basically, it will increase the temperature in the room rather than cooling it. But we can do some modifications to it. Basically, we can keep the condenser and the compressor outside the room, basically like an AC. So then it will start acting effectively as an AC.
But the size will also matter.
Ah, yes, size will also matter. But if you want some cooling, then we can modify it like that.
Okay, good. Why food cook faster in pressure cooker as compared to
Okay.
we cook in open uh,
So
utensils?
basically, what happens that in pressure cooker we are increasing the pressure, which means the liquid that is there or the water that is present inside the boiler, it will find it very much hard to evaporate. Which means nothing of the heat energy that is applied, it is going to the phase change. Everything that heat that we are applying is going to increase its temperature itself. So if we increase that temperature, the boiling point of the water will also be increased. Hence, instead of boiling vegetables at 100 degrees Celsius, we can boil it at 140 degrees Celsius, which means whatever vegetables is there, it will boil much faster and cook much faster. So that is the basic principle behind it.
Yeah, steam. And what will happen if tappet clearance more or less?
Okay, if tappet clearance is more, which means the walls will open late and close early. Yeah, which means if it opens late, less amount of charge and fuel can come inside through the inlet wall. Also, less amount of exhaust gas will be expelled outside. Now, if the tappet clearance is very less, which means the wall will open early and close late, which means some amount of compression pressure that is inside the piston will be lost, hence decreasing the efficiency of the engine and not allowing proper combustion to happen also.
1 TR is equal to how much calories kilocalories per hour.
Okay, that is 0.3024 kilocalories per hour or 3.5 kilowatt or 210 kilojoule per minute.
Very good. What is superheat?
Superheat is a state in which we heat a substance beyond its saturation temperature. Like if we're heating a water to 110 degrees Celsius, we are giving it 10 degrees of superheat. That is heating it beyond its saturation temperature or boiling point.
And we can increase its temperature without increasing its
Pressure.
yeah. And the the superheater used in boiler accessories.
Yeah.
So can you define that superheater
So
functions?
basically, we superheat this gas either by using flue gases from the combustion or exhaust flue gases also can be used. So the main thing why we're using a superheater because there will be no amount of moisture present in it. So it will not be corroding anything in the pipeline that is going through any component that is the superheater steam is used for. So no corrosion will happen. Also, it contains much more kinetic energy also the superheater steam. So that is the main reasons behind why we use superheated steam.
Okay. What are the laws of thermodynamics?
Okay, laws of thermodynamics. First is zeroth law of thermodynamics, which says that if a body A is in thermal equilibrium with body C, and a body B is in thermal equilibrium with body C, then A and B are in thermal equilibrium with each other. Then we have first law of thermodynamics, which says that energy cannot be created nor be destroyed, but can be transferred from one form to another. Then we have second law of thermodynamics, which has two statements, that is Kelvin Planck and Clausius. In Kelvin Planck, it states that for a heat engine working in a cycle, it is impossible that it can convert the entire heat into equivalent amount of work without any losses. Basically, it is telling that 100% efficiency is not possible. Now, in Clausius statement, it says that it is impossible to take heat from a lower temperature area and supply it to higher temperature area without any additional work. Then we have final, that is the third law of thermodynamics, which says that the entropy in the system will never be zero, or the system can never actually reach absolute zero temperature because at this temperature, even the atom motion actually ceases to flow. So at that point can never happen in space or in reality actually.
Why these pumps called positive displacement pumps? The pump which is why we call positive displacement pump.
So positive displacement pump are called like that. It is written in its name only. It displaces it positively. It traps the fluid and displaces it positively. Basically, there is no recirculating. Even if we block the discharge line also, it will keep on positively displacing. Nothing can stop it. The volume that it discharges, it will discharge whatever happens. So that's why it is called as positive displacement pump.
What is NPSH?
NPSH is basically net positive suction head, which is a pressure head that we keep at inlet so as to avoid cavitation to happen, so as to avoid vapor bubbles to form. So this there is two things, that is NPSH available and NPSH required. This required is given to us by the manufacturer, and available is what we actually set in the pump. This NPSH available should always be greater than the NPSH required. NPSH we are calculating based on different criterions like absolute pressure available at the sump, then the head that we are keeping it at, then the frictional losses that is there, and also the vapor pressure of the liquid in itself. So after doing all of this calculation, we'll know the correct pressure head we should keep so as to avoid cavitation.
Can you tell the formula how to calculate?
NPSH is equal to absolute vapor pressure plus or minus the head minus frictional losses minus the vapor pressure.
So, do you know the NPHS, the formula of NPHS is changed according to the available of the liquid.
Yeah, basically, if it is above, this head will be positive. If it is below, the head will be negative. The sign changes. That's why I said plus or minus.
What is cavitation?
Okay, cavitation is a process in which the working pressure inside the pump falls below the vapor pressure and vapor bubbles is formed. This vapor bubbles is formed in a low pressure region, and when it reaches the higher pressure region inside the pump, basically the discharge side, it will burst, which will cause an impinging action to the impeller and the casing, hence decreasing the pumping efficiency.
How vehicles start at beginning when we use key? I'm talking about the start of bike or car. If you know both, you can
Okay.
answer.
Okay, basically in car, how we do it, we use a starter motor. So when we turn on the key, it closes the circuit for the starter motor, and it also closes the circuit so that fuel pump is activated, spark plug also gets the energy. So when we start turning the key, the starter motor will start spinning and it will come in contact with the flywheel. So because of which cranking process starts, that is the rotation of cranking. It will rotate at a certain RPM so that after some time the engine can run on its own power. In this simultaneously, the fuel is also supplied, the spark is also is produced. So this is how the car is started.
Can you name the gears name that you used to transmit to that help
Uh,
to turn the crankshaft and the
Basically,
gears?
in bike I can tell clutch hub, but in car I think basically directly to the flywheel it is connected.
No, the gears name. What kinds of many kinds of gear we use. So what kinds of
Okay,
gear
spur gear,
is per gear?
spur gear.
Are you talking about spur gear used in bikes or in car?
And both actually, I think since we are connecting and what is here, one is on the top, one is on the bottom. I think spur gear is more makes more sense to use it.
How lubrication take place in bikes?
What lubrication?
Yes.
So the main thing that we use in bikes is splash lubrication, where there will be a scoop present in the bottom of the crankshaft, and it will scoop some amount of oil and put it all in all the critical places in the engine, basically the cylinder liner, any bearings that is present, and after some time it will all come back to the oil sump.
Can you name the gears name that you use? The pumps,
For
the pumps. What types of pumps you use for lubrications in bike?
in bike, And bikes, I don't recall it using any pumps for lubrication. I
Internal
think
gear pumps. I think so.
internal gear pumps.
Yeah,
Okay,
you
okay.
can check it.
Basically, what I have heard is that first of all, splash lubrication or using the nozzle. But I think to develop pressure for this nozzle, we are using internal gear pump.
Yeah. What is die? D-I-E, die.
Tap and die, basically, right? Okay, just to die, if I have to tell, it is a component which we use to manipulate a specimen shape into the die shape. And if you're talking about tap and die, die is used to make threads of the male portion of the screw, whereas tap is used to make the threads for female portion of the screw.
Do you have paper or pen with you?
Yeah,
Can you draw the valve timing diagram of two-stroke engine?
2 seconds. Is it two-stroke petrol or diesel?
Diesel engine. Diesel engine, diesel.
This is how it looks. I hope it's not clear. One minute, I'll take off the blurring.
Arrow, arrow.
Arrow, okay.
And degrees. Yeah.
Yeah, it is there. 60 degrees, 60 degrees, 42 degrees, 42 degrees, 10
And
degrees, 12
mention the
degrees.
name, the compression expansions.
This is compression, this is expansion.
Can you explain it?
Okay, basically the thing that is happening, first of all, the piston will come from TDC to BDC. First, the exhaust valve will be uncovered, then the inlet intake port will be uncovered. So the pressurized charge from the crankcase will be inserted into the engine. Now, after this, the piston will move from BDC to DDC, where it will further compress this charge. And at the end of this, we will get the oil injector. Oil injector will start and start applying fuel into it. Now, because of this compression temperature, combustion will start happening. Now, as it is coming down, we'll get the stages of scavenging. First is this, that is exhaust valve opening. At this stage, there will be a blowout of exhaust gas. That is basically pressure difference between inside the piston and outside. Because of it, some exhaust gas will start going outside. Next is that since the inlet port is open, because of the scavenge pressure that is there, some amount of this exhaust gas will be pushed outside. And the third and final thing is that this exhaust valve closes only after 60 degrees. after the BDC, which means even after reaching the BDC, this exhaust valve is still open, and when it goes to the compression stroke, it pushes out again. That is force scavenging. It pushes out some exhaust gas even outside in that state. So these are all the stages of scavenging.
How many types of scavenging use in engine?
We have uniflow, we have cross flow, we have loop scavenging also.
Can you explain the mix flow?
uh, Mix flow or cross flow basically. So what happens is that inlet and exhaust port is on either side of the cylinder liner, then we call it as cross flow. If it is on the same side of the liner, we call it as loop, and if we call it as uniflow if we have inlet port and exhaust valves.
Uh, can we is the piston change according to the flow of scavenging?
Can the piston change according to the flow of scavenging, like in the respective of combustion happening, or
No, like we know that there are three types of scavenging: cross flow,
yes?
uniflow. So the piston change according to the flow of scavenging, the types of engine. Like as we know that
Basically,
in
if
cross, yeah,
basically in cross flow, what happens is that this piston has some amount of design so as to allow
crown,
some of the inlet freshers to move
yeah,
properly inside. That
crown
design
shape.
factor is also there.
Yeah, piston have crown shaped
Crown shape, yeah.
crown shape. So you have to remember this also. If you will explain this, so you have when you were like when you were explaining about the valve timing diagram, so you said about flow. So maybe he can ask you. So you have to mention, you have to remember that the piston may be changed, the crown shaped and the flat also.
Okay, okay.
Okay. Do you want to draw PV and TS diagram of VCRS system?
Is it visible?
Yeah, yeah, it is visible. Correct.
Yeah.
Rashid, what is the difference between fusible? What is the difference between relief valve
I
and
think you are
bursting?
muted.
What is the difference between bursting disc and the relief valve?
So both we are using to relieve the excess pressure that is in the system itself. But basically, relief valve is used because it is a slow acting safety valve, and bursting disc is a sudden acting safety valve. Basically, relief valve is used in a case where we are not expecting a sudden change in pressure. But in bursting disc, we are actually expecting a sudden change in pressure. That is the difference between the use cases of both.
What are where we use relief valve?
Relief valve we can use in gear pump because of excessive pressure inside it, and bursting this we can use in intercooler and aftercooler of compressor also.
Can we use
Basically,
relief valve instead of bursting disc in intercooler and aftercooler?
we can use it in the air side but not the water side. Basically, we are using the bursting disk on the water side and relief wall on the air side. Because what happens is, in air side there will not be a sudden increase in pressure, so we can just use the relief wall. But in the air side, basically what happens is some amount of this air, sorry, bursting disk is on the water side, and relief wall is in the air side. So if some amount of air is leaking out, suddenly around 30 bar of pressure is leaking into the water side, and the casing of the intercooler or aftercooler will not be able to sustain such high pressure. Basically, if it's made of cast iron and all, it will basically act like a sharpener when it bursts. So as to avoid this, we are using bursting disc. But relief wall can't act as a bursting disc because it is not as fast acting as bursting disc. We need a fast acting safety valve here. So that's why we cannot use the relief valve uh, instead of bursting disc.
Do you know back pressure valve in VCRS system?
Back pressure valve. No, I don't know.
Okay, you are good.